In this video, we're going to discuss data and its visualization. Hopefully, a lot of this information will be a review of information that you had in previous courses. If not, you may want to stop and pause and make extra notes as we go. So, data and its visualization. Data, first of all, if you'll recall, is the actual responses or values you get when you're asking about a particular variable. So, for example, if you're interested in determining the most popular eye color, then you may ask, what is your eye color? And you'll get responses such as blue, green, hazel, or brown. You may be interested in the average height of individuals. And so you would ask, what is your height? And you might get responses like 5'4" or 6'2" You may be interested in age, and you would get responses such as 18, 47, and 23, or a salary for a particular position, and you might get responses like 25,000 or $42,500 or $38,975. Okay, so again, data is simply the actual responses or values you get when you're asking about a particular variable. Again, political affiliation would be an example of a variable. Data, if you'll recall, is classified by its characteristics and whether it is words or numbers, and also its level of measurement. And knowing the type of data that you have in a particular research study is important because it helps you to determine what types of statistical analyses you can and cannot do. So it's really best from the beginning that you identify what type of data you have. So we're going to review how to do that, how to classify data by its characteristics. One method for classifying data is by type, and this kind of flow chart shows you how, or diagram shows you how it breaks down. Data can be classified either as qualitative or quantitative. Qualitative is the adjective form of the word quality, and it's sometimes called categorical data, but it's going to be labels or descriptions using words or phrases. So the idea of eye color, where you're getting blue, green, hazel, brown, or the political affiliation with Democrat, Republican, Independent. You have to be careful though, because qualitative data can be numeric. It can be a number, but it's not usually a number that is used in a calculation. For example, your social security number is simply a label. It's how the government tracks you and would be considered qualitative data, because I'm not going to find the average of a group's social security number. Your Georgia Highlands ID number would be another example. Your driver's license number, the number on a jersey for a particular player, whether it's in football or baseball or softball. So qualitative data is words or phrases primarily, although it can be labels, although it can be numbers, but it's not used in calculations. The other classification by type is it can be a quantity or quantitative. Quantitative is the adjective form of quantity, which hopefully makes you think of numbers. Okay, so quantitative data is always going to be numbers, typically associated with counts or measurements, and those numbers can be used in calculations. Quantitative data can be broken down further into whether it is discrete or continuous. Quantitative discrete, typically the description will talk about the number of, like the number of students in the classroom, the number of credit cards you have, the number of phone calls you receive in a day. Typically discrete data is associated with counting. It does not involve fractions or decimals. It's going to be whole units. And then quantitative continuous, always think about a continuum where you're using some sort of measuring tool, and you can have fractions or decimals. Because we talk about temperature, for example, can be 98.5 degrees Fahrenheit is normal body temperature. A person can be 5'6", so you can be part of an inch. So anytime you're measuring things like height, weight, so forth, that is considered continuous. So data can be classified by type, either as qualitative, quantitative discrete, or quantitative continuous. Those are your three choices. We also can classify data by level of measurement. And again, it still is associated with the idea of being qualitative or quantitative. And there are 4 levels. And the higher the level of measurement, the more mathematical calculations we can do, and the more statistical analysis options that we will have. The lowest level is nominal, and it is connected to qualitative data, or is only applicable to qualitative data. Nominal is the adjective form of the word name, so you're thinking about just straight out categories. There's no sense of order, and you would not do any calculations. Here again, this would be things like eye color, okay? Having green eyes is not necessarily better than having blue eyes, so it's just categories. Being left-handed or right-handed would not make a difference. There's no sense of order. It's just a label. The second level is ordinal. Ordinal, you still have qualitative data, so it's words or phrases, but now you have subjective ranks, meaning it's open to the interpretation of the researcher or of the individual. Ordinal might be things like letter grades. We know that an A is better than a B, and a B is better than a C. Other things would be things like a chili cook-off contest, or some kind of baking contest where you have first place, second place, third place. And again, that's subjective based upon those folks who are judging it and whether they really enjoyed your food or not. Even at the ordinal level, there are no calculations because we're still dealing with words and phrases. As you step over to the third step at the interval level, we begin our focus on quantitative data, or numbers, regardless of whether it's discrete or continuous. So the interval level, you're going to have numbers. There is an objective order. I mean, it's an order that would make sense. Thinking about a number line, 1, 2, 3, 4, 5. You can add and subtract at the interval level. The one piece that tends to really bother students is that at the interval level, we have no true zero. Zero is simply a placeholder. For example, temperature, if I say that the temperature is 0 degrees Fahrenheit, that does not mean there's no temperature. That is simply the point at which we begin measuring, and it would imply that it's really cold outside, or I suppose it could be inside. Okay, so there's no true zero. Again, think about IQ scores at the interval level. An IQ score of 0 does not mean you have no intelligence or no brain. Okay, it just means that's where the particular measurement started. The final level is ratio. At the ratio level, again, you have numbers. Again, you have the objective order, so there's a sense of, a person who is 17 is younger than a person who is 23. So again, you can begin to make those sorts of comparisons. At the ratio level, you can add, subtract, multiply, and divide, so you can perform all 4 basic operations. And at the ratio level, you have a true zero. So 0 would imply none. So if I say there are 0 students in the classroom, there are no students in the classroom. Or if I say there are zero, I got 0 phone calls today. That means I didn't get any phone calls. I got no phone calls. Okay, so that's your levels of measurement. And again, you need to be able to classify your data by type as well as by level of measurement, because again, that's going to help you to determine what statistical analyses you can do. In today's world, all types of companies, regardless of the industry or the size, are inundated with data on a daily basis. So are you. You cannot hardly open a newspaper, look at the internet, watch television, or even listen to the radio without being inundated with data. Quote, big data can be analyzed to reveal patterns, trends, and associations. That term, big data, is new, it's recent, but it refers to large, diverse sets of information from a variety of sources that grows at ever increasing rates. With the advent of technology and the internet, we have access to lots and lots and lots of information. And we do have to evaluate whether those sources are valid or invalid, but we can get it almost in real time. The importance of big data doesn't revolve around how much you have, but what you do with it. You can take data from any source and analyze it to find answers. And that's one of the things we're going to be talking about as we go throughout this course, is how to analyze it. Data scientists spend 50 to 80% of their time organizing and preparing data before it can actually be used. You have to get it organized in a fashion that it can make sense, that you can present it to other people so that you can actually make sense of it. One of the key tools in that organizational process is to create pictorial or graphical presentations of the data, what we call data visualization. So data visualization is a pictorial or a graphical representation of the information and the data. It's a very quick and easy way to kind of begin to see the trends, to see if there are outliers or any patterns within the data. Data visualization is universal. It's used in all types of industries, in all countries across the world. Our eyes tend to be drawn to color and patterns. So a display often involves colors and patterns. It also helps us to tell a story, but to tell a story with a purpose. But it's a delicate balancing act, because you don't want the picture or the graph to be too overly distracting. You want to get your information or your point across. It is also considered a form of visual art, because it's going to grab the researcher's interest and keep their eyes on the message or the information that you're trying to communicate. So why is data visualization important? Again, it's in a very easy way, using a picture or some sort of graph to help us understand lots of information and data very quickly. Especially think about news reports on the television and that sort of thing. Humans can process visual images 60,000 times faster than text. It enhances communications between your stakeholders, which leads to a faster decision making. If you're presenting this to a particular board that are ultimately going to make a decision for you, the graphics, the data visualization is going to be a lot more useful and help them to see it a lot quicker. It helps you to identify relationships and patterns within the data. It highlights emerging trends within the data very easily. And again, it communicates kind of that story, or helps you to create a story or a message, again, to others and to your stakeholders. Pictures are worth 1,000 words is an old saying. So images speak louder than words. It also may help you to identify an area or a particular topic or a particular category that may need additional attention or improvement as you go through those. And we're going to look at in a separate video some of the different visualizations that you can create depending upon what type data you have.